title is a two variable K-map. We start with the example, which is fxy is the function with two variables. So it is sigma m0, 1, 3. Okay. So the first thing is, whenever you want to use the K-map, definitely your function should be the form of the standard form that you see our function f is in the standard form, right? So let's see how we could simplify these function and how you could use the K-map. So whenever you have function with two variables, so your K-map has 4 sections. So that means the shape of your K-map is something like this, which include to 4 square, okay? Usually in this side, you put the first variable, which is x, and in the other side, you put the second one, okay? So here you actually write the all possible values that the y able to get. Definitely it is binary, it's just get to 0 and 1. And here usually you write the all possible case that x could be get. So definitely it is 0 and 1, okay? So each actually square that you have here represent a midterm number. So for example, this square that you see, if you check these x, it has the x is 0, the y is 0. x 0, y 0, this should be represent of midterm 0. Go to the next square. So the x is 1, the y is 1, okay? So 0, 1, it's represent the midterm 1. I just write 1 here. Go to the next square. So x is 1 and the y is 0. X is, so I'm here. So the x is 1, y is 0. So it should be 2. And here again, x is 1 and y is 1. So this is represent midterm 3. Okay. So the first step, you just complete the K-map based off these explanation that I give to you. So then take a look to whatever you have inside these parentheses or standard form, and you already know in these midterm the function is 1. So that means back here you have 0 inside parentheses, you write 1 here. So midterm 1 is this, again it is inside the standard form, you write 1 here, and the 3 still is here, and you write 1 here. Okay, this is a next step. So the step number 3 is, which is the most important one, you need to actually group these one that you see in these K-map. So for doing that, so there is one rule. The rule says, okay, whenever you group these one that you see on your map, you need to do this. The number of the group should be minimum and their member should be maximum. Okay, so I'm here summarize that. So the group that you make, the group should be minimum number of the group. Their member should be maximum. And also you could just able to, whenever you are grouping different one that you see here, you just group 2 1 which they are adjacent. So that means they are actually close to each other. So the group should be the adjacent one. So let's see what it means. Let I select another color here. So see how many options here I have. So the other thing is the member of the groups, which is should be the maximum, and the member should be just, you could have the group with 1 member, group with the 2 member, group with the 4 member, group with the 8 member, group with 16 member, 32. So these are the number of the member. You couldn't say, okay, I'm here, I select these 3 as a one group. Okay, group couldn't have 3 members. It should be 1, 2, 4, 8. Okay, so let's take a look to start with the smallest one, 1. So could I get 3 maybe I rewrite here, which is give you a better idea of what I'm talking here. So we have 3, 1, okay? So could I take 3 group with 1 member? So see, this is 1 group, this is second, this is third one, and each of them has a 1 member, which is the member could be 1. So this is one option. So someone else comes here and say, okay, how about this? I have 1 here, I have 1 here, I have 1 here. So could I have the member with 2 groups? The answer is yes. You could have these 2 as a 1 group. They are adjacent, right? They are close to each other. And also this is second one. You could have some common member between different groups. Okay, it is possible. So here the number of the group is 3. Their members is 1, right? How about this case? So here the number of the group you have is 2. Their member is 2. Okay. So we have someone else. It says, okay, I don't like what you did, so I want to do this. I want to take this as a 1 group, and this is another group. So that means again number of the group is 2, and the member you have actually 1, which is this group with 1 member, and the next one is 2 member, which is this group that you see. Okay, so this is a rule. Again, back to here. So here is the rule that you have. The number of the group should be the minimum. So that means if you have the option with this 3 group and here your option is 2 group, so the right choice is 2 group, not 3 groups. Okay, all the time the number of the group, you should try your best has minimum number of the group. Okay, so here you have 2, here you have 2, so the both could be at least for these level should be fine. Okay, definitely we refuse this because the group numbers should be the minimum. Here you have 2, here you have 3. We refuse this one, okay? So second rule, the number of the members should be maximum. Here you have 2 groups with 2 members, but here you have 2 groups, but one of them has 1 member, the other one has a 2 member. So the number of the members should be maximum. Here is the maximum, which is both has 2, but here one of them has 1, which is we refuse this one too, okay? So that means the right group here is whatever you see here. So you could say, okay, I select these 2, 1 group, and these 2 common is the another group. So I actually consider these rule that I have in the K-map. The number of that adjacent one, the number of the group should be minimum, and they should have the maximum member, right? So that's the reason I refuse these 2 that I have, okay? So if you consider these 2 rules, so whatever you got, you make sure it is the simplest form of this function, and you couldn't get more simple than this form that you have, okay? So what is the next step? Next step is write the term for each of these group that you made in this level, okay? First, consider this group that you have and see how I am writing the corresponding term for each of them. So first, I'm writing about these 2, which is midterm 0 and 1. So you take a look to whatever you have on the left side, which is here. So this is this group. Here, the x is 0. Here is x is 0. So let I raise this. Okay, so let I raise this and add one more comment here. So you take a look to the each group and see what's the value of y change bit inside these groups. So first the x. So here the x is 0 for this group with 2 members. X is 0, here x is 0. There is just 0 and 0. So whenever you just have a 0, 0, the corresponding variable, which is x, get the prime, okay? So whenever it is 1 and 1, no prime, just somehow similar with what we had for the midterm, right? Whenever it changed from 0 to 1 or 1 to 0, you should eliminate or delete the variables that you have. So that means inside that term, you don't have that variable, okay? So see how I'm writing the corresponding term for these groups. So here, in this member, the x is 0, you move to the next member is 0. So that means 0, 0. The variable which is x should be get the prime. So then I'm writing x prime. Take a look to the y. So y here is 0. Here in the next member, the y is 1. Here is 0. Here is 1. So whenever you have 0, 1, you delete, you eliminate. There is no y send y term here for the first term for the first group, okay? So I'm done with this group, okay? Now I write the corresponding term with the second group, which is midterm 1 and 3, okay? These group that you see. So again, take a look to x. It has two members. In the first member, the x is 0. In the next member, x is 1. Change 0, 1. I will not have any x in this term. And take a look to the y. So here y is 1. In the next member again, y is 1. So 1, 1 should be no prime. Okay, so that means you just write actually the y. So that means the simplest form of this function is x prime plus y. Okay. So definitely, if we get more examples, it should be make more sense. Okay. So let's do have one more example. Again, stay on two variables. Another example for K-map, if x and y equal to sigma midterm 1, 1, 2, 3. Okay. 1, 2, 3. So the question is use the K-map and get the simplest form of these function. Okay. So back to this one, the similar with the previous example. You have a function. It has two variables, and you want to use the K-map to get the simplest form of that. So as you already know, the K-map should has 4 different part. So here you put x, you put y, here is 0, here is 1. So again, here is 0 and 1. So you could put this 0, 1 in any order, but we use in this way. So if you put the other order, it should be a little different, but you end up with the same answer. Just let to all of us use these order, which is 0, 1, 0, 1, because we want to end up with the same simplest form. So as you expect here for this square, the x is 0, y is 0, the midterm number is 0, here is 0, 1, this should be 1, here is 1, 0 should be 2, and this one is 1 and 1 should be 3. So back to here to inside the midterm. So you have 1, 2, 3. So you just put the 1 here, you have on 2, and you have on 3. Okay. So now the question is how many group we could have, which is have these rule here. The number of the group should be minimum and their member should be maximum. So let me know how many groups you actually selected here, which is you want to end up with the minimum number of the group and their member should be maximum. So if you consider that two rules, how many groups do you have here? Type on the chat box. 2, 3. So see, if group is 2, tell me what's your option. You are telling me 2 groups with 2 members or 3 groups with 1 member. Definitely we refuse the 3 groups because the idea is the number of the group should be minimum. So definitely 2 is the right option. And 3 is definitely don't give you a simplest form of the function, okay? So you got this. Okay, so I don't know what's happened here. So this is the first one, and this is the second. Okay. So again, usually start with 1, 2, 4, 8, and 16. First say, could I get the start with the biggest number? Okay, the first question is because number of the members should be the maximum. The maximum you could have here with the two variable is 4. Do I have any group with the 4 members? The answer is no. If you want to have, you should have one here, right? So you actually group the places that you have one. Okay, there is no one here. You couldn't have one group with 4 members. So no group with 4 members, then check the members by 2, the group with 2 members, which is here. You could actually have these two, and that's it. If that's not a good idea to take the group with the 1 members, because the rule is minimum number of the groups and their members should be maximum. So that means this is the right group here. So then write the corresponding term for each group. So the first is group that you see, min term 2 and 3, check the x. X here is 1, in the next member is 1. So you have x. How about y? Y here is 0, y here is 1. 0, 1, you don't write that variable. So back these two group. Here x is 0, here x is 1. No x in this term, and y is 1 here and also 1 here, which is y. Okay. So that means the simplest form should be x plus y. Each of these terms comes from these groups that you have. Okay. So this one, this group that you see, which is in 1 and 3, is corresponding to this term that you have. Okay. And this group, which is 2 and 3, it is actually give you this term that you have here. Okay. So first, I'm writing the corresponding term for these 2 and 3. Okay. So how many members I have? This is 1, this is 2, right? So this is 1, this is 2. Okay. So here in this one, which is 2, what is the x? X is 1. So here, what is the x? Again is 1. So back to what I mentioned, whenever that's 1 and 1, that variable get no prime. So definitely it has x. Okay. So how about the y? So you check the other axis that you have. So this one. So here the x for this member is 0. For this member again is 1. Whenever it changes 0 to 1, 1, 0, you eliminate that variable, which is y. So that means it's not has any xy or xy prime, just is the x. Okay. So same thing for the next. So again, you consider second group. For each group, you are writing the corresponding term. Okay. So for this group, check their x. This member x is 0. This member x is 1. 0 to 1, 1 to 0, you eliminate or delete that variable. So that means the x is gone. So that's the reason you couldn't see any x here in this term. How about y? So here y is 1, and in the next member again y is 1. 1 and 1, it's actually no prime. So that's the reason I just put the y, not y prime. Make sense?